Hello, welcome to the data channel, and you are watching Microsoft Fabric concepts in this tutorials. So we are bringing up the new video today as part of the Microsoft Fabric playlist that is OneLake. So OneLake is heart of the Microsoft Fabric, and we will discuss in detail about Microsoft Fabric OneLake. So if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. Before exactly going to the OneLake concept and discussing what exactly the OneLake and as part of the Microsoft Fabric, why Microsoft is bringing OneLake. So we need to understand the little bit of the problems behind it and the current problems that the data world has and the enterprise level. What are the data challenges in the data engineering field and kind of bringing the data in different layers, what exactly is causing the problems for the enterprise and why the micro so if you understand that, so will come to know why Microsoft Fabric has brought in the concept of OneLake and also the Microsoft Fabric concept, right? So if you see the data lake architecture, if you are familiar with data engineering or if you're working with data with the cloud, so definitely you might have heard about data lake. So data lake architecture predominantly so this is a typical data lake architecture in any project or any enterprise level project you see. So there will be a different data sources. It might be structured, unstructured, semi-structured, right? And then you perform a data ingestion from that sources. So when you do the ingestion, you need to connect to that sources, right? Using some connector or some programming language, and you extract the data in batch or real time, and you physically bring that data to the something called as a raw layer or data lake, raw layer or landing layer, right? So this will be again, it might be any kind of storage. Usually it might be data lake, AWS S3 bucket or blob storage. So any kind of storage, or it might be any tabular kind of storage also, or also like Cosmos DB, anything, right, for that matter. And then you process the data and again you store it in some other format. It might be if you are using for the data consumption as a Power BI or for analytics, right? BI analytics, right? So then if you want to report the data to the business user, so you again put the data into the analysis service. And if you are want to give the data to some kind of search engine where you have want to optimize you want to have the good performance, right? So then you might put into some other kind of storage which is suitable for that use case, right? So that actually causes the data duplication, as you can see here. So the data is having multiple hops. So the data comes from source to raw layer, and again you process it, you put in a transform layer. And when you're putting to transform layer for each different use cases, you might need to put the data in different formats. Suppose if you want to expose the data to a kind of a reporting layer like Power BI, so you have to put it in analysis service. Or suppose you want to put the data for give the data for data scientist, you have to give the data in different like particular format the data scientist needs. So it might be Parquet or any kind of format that a data scientist needs, that team needs, right? So you will create one more copy of that data because the format is not suitable, right? And say for example, if you are using for a API use cases where you want to send the data or you want to you want to push the data outside the world using some API, right? Like it may push API or pull API. In that case, you might use Cosmos DB, right? So it's again one of the use case. So what exactly you're doing here is the same copy of data you're replicating in multiple layers because you have multiple use cases, right? And you can imagine the resources, skills that is needed, and also the data duplication you are doing, the data storage, the cost. So all will come into picture when you are designing such solutions. So since volume is growing and the enterprise is getting more matured, so this is becoming a problem. So hope you understood the problem of data lake architecture, right? So now let's go to the data mesh kind of architecture. So if you see data mesh architecture, so it is predominantly trying to solve some of the problems that data lake had. what it does is, in this case, so it will say don't bring the data, or don't centralize the data. So keep the data in that respective domains or the business unit. Suppose you have a marketing department, so you have a finance department. So here, what exactly they say is, so finance data to be kept in the same in that domain, right? So they are calling it as a mesh. Okay, and service related team, they will keep their data. Sales related team, they will keep their data. So basically, we are not bringing the data physically to any one location here, right? So here, one location, we are not bringing the data physically, I mean, right? So what happens is here, like there are multiple advantages, right? Because that previously we have seen, so there are a lot of disadvantages of physically bringing the data into one location and doing transformations and all. So here we are not doing that. So this is a concept of data mesh, right? So even in data mesh, there are few challenges. This is, data mesh is a conceptual kind of. It is not a. It is not a like data lake, right? So data lake is actually, it is having some physical presence where we have a data lake implementations done by Azure and all. But Fabric, if you talk about Fabric, it is a conceptual module, and so it is trying to address some of the challenges that data lake or centralized data repository has, right? And even if you take data lake or data mesh, even in case of data mesh, there are few challenges where the data gets siloed, and hence the data redundancy can happen, and complexity, and the data can get fragmented, right? And so if you take, like say for example, in this case, even in this case, if you are not moving the data physically, right, what happens is, so the data that marketing team is generating, finance team is generating, is completely siloed, right? So we don't know what's happening in between these teams. So they are not communicating. So this is a problem of data mesh. Okay. So both problems are a little bit, we can say, like Microsoft has understood it in a better way and trying to solve this problem together using a concept of OneLake. So OneLake Microsoft is a concept of Microsoft Fabric, and it's a heart of Microsoft Fabric. Why we call that is, so you see different services: data factory, Synapse, engineering, data warehouse, Synapse data science, real-time analytics, Power BI data activator. All of these are services, and all of these services are dependent on the data that is given by Microsoft OneLake. That is why it is a heart of the entire Microsoft Fabric architecture or the concept, right? And we can also call it as a OneDrive for data, like so you know, right? So if you're using any enterprise, there is a OneDrive. So it is just you're dumping the data to the OneDrive, and you use the data from different laptop, right? You use the data is shared with the different teams. Okay. So, and there might be a different folders for different teams created. Okay, and you can get the access for that folder, and everyone in the team can collaborate and share the data. So the same concept, similar concept of OneDrive. And it is called as a OneLake here, and it's a unified logical data design for enterprise use. And why we are calling it as enterprise, because it is trying to solve the enterprise challenge that we have discussed, right, in the previous slides. And it is a single repo for all the analytics. That means it is a single repo, means it stores all the data in one place, right? And for the entire organization, suppose you're working for an organization XYZ, so this particular organization data, the entire data of this organization is stored in one place. Okay, that is called OneLake, and this will be shared across different teams and different geographical locations, so that we will see how it can be done in the later slides. And this particular is a rich SaaS, is a SaaS application, that is a software as a service, and it's core of a fabric, and it's a fully managed and fully governed. So why we're telling is a fully governed is very important, because since the data is in one place, it is very easy to manage and also apply some compliance related and data governance related policies, and the data is in more control, what we can say. And one copy of the data used across multiple analytical engine. So that's what these are, analytical engines, right? So only one copy of data is used here. That means suppose you are a data engineer, you want to bring the data from XYZ sources to your blob storage or Azure, then perform analytics, then give it to then give it to the different team in different format. So put it into AAS, right? Analysis service, then Power BI will come and access. So here it is not like that. So data engineers will use the same copy of the data and process it and store it in the OneLake, and the Power BI person will just read the data from OneLake. He is not at all depending on the data engineering team. Or like if you are a data scientist who want to use data science use cases, you can just use the same copy of the data which is there in OneLake. So you need not ask for the different format. So if data science might need a different format of the data, it doesn't matter. So here what's happening is all the data is stored in a particular format. So that is why so all these services use the same copy of the data, right? And it works basically it's for the entire globe. Basically there is a one copy, right? So that's why it avoids the duplication of the data, and it works on the concept of tenant for one organization. That means so each organization, suppose you like say take XYZ is a organization. For this organization there will be one tenant ID, right? So for this tenant ID, so the entire organization data will be tagged to this tenant ID, and that will be stored in OneLake. So and the tenant admin will be there. Like if you are familiar with the Power BI kind of a use case, right? Like where the tenant admins will control the data, control the access. A similar way, here the tenants can tenant admin level, they can control which team needs to have access for which workspace. And like SharePoint and a team users have their own workspace like Power BI. Suppose if you are working in a like a team one, okay, so you will have you will have workspace one, say for example, and if you are working for team two, you will create your own workspace, that is workspace two. So it is very similar concept of Power BI, right? If like in Power BI also we create a separate workspace for each project, each geographical locations, and host the dashboards. In the similar way, you will create your own workspace to dump the data in that workspaces, and each the collectively all these workspaces. Okay, there might be like many a number of workspaces, and all the workspaces will be tagged to the same tenant. Okay, and that is why all the data will be logically will be in the one lake, right? And workspaces may be at a like country level, or you can have workspaces at a project level, and you can have your own restrictions set up that will be controlled by the tenant admin. So but there are at one lake which is a tenant level, which is again a global, right? So now we can see like if you open the one Microsoft Fabric UI, right? So you can see there is a workspace, sample workspace here. Similarly, you can create your own workspace, and each workspaces can come and dump the data here. And if you see, it shows like Power BI because it is like looking like a Power BI. Okay, this Microsoft Fabric also has the same kind of a UI. So if you are familiar with the Microsoft Power BI, it looks very similar, and you can create your own workspaces, and you can start dumping the data into that workspace, and internally it will go and store the data into the one lake. So basically what we are trying to do is eliminate the data silos, right? And more that allows logical data management, allows different business unit handle their own data, right? And it is similar to the data mesh, right? So that is why we see different views can have different their own workspaces here and to maintain their own data. So in the next slide, we will just discuss like how the one lake is built. So one lake is built on the top of ADLS Gen 2 concept. That means ADLS is a concept of data storage in Azure, which is the Azure Data Lake Storage. It's a generation 2. So basically, if you talk about Microsoft Fabric, right? So the Microsoft Fabric is internally storing the data in ADLS Gen 2 in the format of delta parquet. Okay. So delta parquet we will see in detail. If you are already knowing this format, if you are working in data engineering uh, domain, so you might already heard about it. If you not, don't worry about it. So it is just a file format. So it's called as a delta and parquet. So it's a parquet format is it's a format which is mostly used for the high performance, right? So it is a file format where the data will be stored in ADLS Gen 2. So whatever data you dump, suppose you dump a CSV file here, okay, it will get converted and it will be storing as a delta parquet. Okay, and if you suppose you dump a SQL file here, it will go and convert into a delta parquet format. Suppose you dump here table, okay, tabular format, or suppose you dump unstructured data, okay, so it will just go and dump as a delta parquet. That means whatever you dump the data into this fabric OneLake, so internally it is stored in the delta parquet format. So it is everything is stored in that format. Okay, so that is a very important concept to understand here. So so if you want to understand the internal architecture of the OneLake here, yeah. And so if you are basically, like, if you want to understand like how to consume this data from any code or any application, right? So definitely what happens is like this is the um, like format you need to use, right? Like OneLake, DFS, Fabric, Microsoft.com, and here you need to give the workspace name and whatever the file name, and then path and file name. So also it supports, this is for the data lake kind of a usage, right? And if you want to like blob storage, Azure blob storage file system format also it uses. So if you're familiar with blob storage, it actually like instead of container you are giving workspace here and at the rate whatever the Microsoft.com and followed by the file name and other things. So we will discuss in detail about this in the upcoming videos. So finally we will see the compute part of it, right? Like we have already seen the concept of OneLake. So how the OneLake will interact with the compute layers, right? So basically, as you can see, this is we've already discussed. OneLake is a storage format, right? And so where exactly the data is stored in the one particular format, right? And the next is like you can see there is one more layer we are adding here, the serverless computing. So where we have a T-SQL, Spark, Kusta query language, and analysis services, AAS. So in this case, what happens is the goal is not to move the data. So that's the concept of OneLake, right? So we have not moved we are not intended to move any data from one service to another service. That means if you take an example, if you are working on a SQL, right? So like you did not bring the data to your SQL storage and then apply the transformation. And if you are a data engineer who are applying a Spark transformation, you do not bring the data into your uh, blob storage or ADLS. Basically, you can just simply start working on the data on the day one because the data is stored in the OneLake, and the T-SQL developers, Spark developers, Kusto query language developers, analysis service from the Power BI. So everyone are using the same copy of the data, and there is no data movement happening, right? And one file is placed in OneLake and share it with all the services. Suppose there is a CSV file, so that CSV file will be placed in a OneLake, and this T-SQL developer can use that, Spark developer can use it, Kusto query developer can use it, AAS service developer can also use the same data, right? And once so it actually what's happening here is it just providing the shortcut. That means so if you are using take the example of CSV again, right? So it is stored in the OneLake, okay, and it is giving the shortcut to that data. That means it is not actually physically bringing the data into your location where you're doing the transformations. So that is why exactly it is giving the shortcut to you, right? So just like a pointer basically you are getting. Suppose let's take you are working in different workspaces, right? Yeah. So take example here, right? So if you are working in different workspace, this is a workspace one where you are business unit one, and you are working in another team is working in workspace two, which is the data is stored for the business unit two, right? And suppose like there is a use case where the workspace A, that is the team, this particular BU wants to consume the service telemetry data, which is of the which belong to the different team. So what happens is the data here actually whatever they are bringing from for the service telemetry data, actually it is underlying, it is stored in maybe stored in Amazon S3 kind of a storage. But what exactly when a particular data engineer or a particular warehouse integration data science any team right here runs the query or runs the service here, what exactly happens, right? So it if your Power BI reports runs on this customer 360 data, and which brings the data also from the service telemetry, so it's actually physically not bringing the data from this location, it's not physically bringing it. So it's a logical kind of a it's like a mount. Like if you know about Linux, it's like a kind of mount point. If you are familiar with Windows, it is like creating a shortcut, right? So you're just creating a shortcut here. It is the physical data of service telemetry is not stored here. So whenever like any of these services wants to use customer 360 data and service telemetry data, right, via this business unit one, that is workspace one, so it uses the the shortcut and it brings the data here, and it will actually process the data. And also you might think it might be when the data is not being bought physically, it might also create a performance impact, right? So that kind of a use case is also considered. And what exactly Microsoft is doing here is it is having a one more concept. So that concept is basically a smart caching. So what that smart caching does is it will bring the data close to the computer. So this will reduce the egress kind of a case. Like suppose you want to bring the data from Amazon S3, right? So it has its own cost implication if you want to egress the data from the Amazon S3. So it considers all these use cases. It does the smart caching. So that is a very important concept here, which that the Microsoft Fabric takes care of, which is the concept of smart caching. And So finally, if you take right example, like if you are a database person, right? So even if you're a database person, you can use the same data, right? If you go back to the slide, so you are using the same data here, which is stored in OneLake, right? If you are a data engineer, you are storing using the same data which is there in OneLake, right? And suppose if you are an end user who want to consume the data, the same data, right? Direct lake. So there is from the Power BI, right? We can create something called as direct lake mode. So this is direct lake mode is actually one of the new concept that Microsoft Fabric is bringing for Power BI. So in the Power BI previously we had only the uh, different cases like where you want to import the data, and there is one more called as direct connector. So here the concept is direct lake mode. That means it will eliminate the import mode, and also it is faster than the direct query mode. So it combines the power of both import mode and the direct query mode. That they are calling as a direct lake mode in Power BI. So and so you understood the kind of a scenario, right? So whatever use cases or whatever services is you are using here, so you are not moving the data, but only using the one copy of the data, and entire data is abstracted basically, right, using a concept of one lake. And you do not worry about the format of the data, you do not worry where the data is, you do not worry about the governance. So entire thing is taken care here in terms of governance, security, because everything data, all the data is in one place. And there is no longer need to set any boundaries on skills, because every team, whoever knows SQL can use, whoever knows Spark they can use, whoever is comfortable in analysis service they can use, and Power BI they can use their own languages. So there is no restriction, and it is fully enabling the contribution and the collaboration between the teams, and also eliminating the data silo problem, right? And finally, since all the data in one place, it can also power up the AI use cases, and the organizations are looking forward to this, because so once the data, all the data are in one, or is in one place, right, particular in one lake, so they can start utilizing the power of AI here. Basically, kind of because in the current scenario, what's happening is data is spread across in different file formats and um, different different locations, different storage locations, and data is duplicated, redundant. So there are a lot of data problems, data quality issues. If the data is stored in one format where all the teams are using, right? So organizations are also keen to do this from the enterprise level, because once this organizations brings all the data and achieves the one lake conceptually in their organization, they can start thinking of the AI, and kind of get that use cases, and encache the any use cases that they can build using the artificial intelligence. So this was the concept of one lake, and hope it was useful. Thanks for watching.